it's time for our AI panel, which I've sort of titled, AI in practice. Now, for some reason, AI thinks that a scientific instrument looks like something that came out of Iron Man 2. But it's a very interesting probe into, how an AI might generate a set of slides, but also sort of its quote unquote cognitive process. And I put that in big air quotes, right? Okay, so the format of this panel is a little bit different than yesterday's panel. Is it's meant to be more of a free-form discussion around a couple of different topics, and so. Essentially, I am going to spend a few minutes sort of setting the table, so to speak, and then I would encourage each of our panelists to give a brief but not too brief introduction. So somewhere around 4 or 5 minutes about their background and their expertise in AI in practice and in AI in sort of practical aspects, right? And then I will go through and we'll have a little bit of discussion, and panelists are encouraged to also have dialogue. So, if you have a question of another panelist around a particular topic, I think that is fantastic. And then we will open it up at the end. And so one of the motivating factors when I was writing this tech report and when I was thinking about this panel was that once again there are these illusions of competence that I talked about earlier, right? And so there's this famous MIT report from last summer, which showed that of industry people, industry corporate entities, et cetera, that were polled that are trying a enterprise AI. Many of the pilots, 95%, at least if the respondents said that they failed to deliver measurable value. Now, this has been a somewhat controversial paper, and there's been a lot of question about that 95%. But the thing that came, across clearly is that there's a lot of people experimenting, but there's also a lot of people who are having trouble getting value from those experiments, and that's without question. The more interesting thing, I think, for us is this Becker et al. Paper from last summer, which looked at experienced programmers using software engineering agents to help them develop open source software, right? And it's a great study. I would suggest people have a look at it. But the once again back to the illusions, right? The folks that were chosen to use AI to solve a GitHub issue, right? They had a perception that their time was actually sped up. Like it took them far less time than it would have taken them ordinarily to write the code or solve a particular issue. But if you objectively measure it, it actually took them 19% more time in overhead of supervising the AI. So there was actually a net decrease in productivity of 19%. Now, I think that's changing, but these are sort of these things. And once again, we also have this situation where if you look at the Gartner hype cycles, right? When they're going out and doing these surveys, and they said, are you going to use agents? And so right now, virtually no one is using agents, at least at the time of this survey in mid 2025. But they all said, at least 40%, like, oh yeah, we are definitely going to be, pushing those into production. And so, that there is this hype, there's this desire, but also there's a disconnect in terms of what things can do. And this is getting, sort of interesting, even over the last month or so. And so there's sort of been this end of year reflection. So one of the ones I'll share here is that Simon Willison, who was one of the founders of the Django project, which is a web development platform in Python. He was highly skeptical, did not use many LLMs this last year, right? But toward the end of the year, especially with Opus and Claude, he has said that his mind has been completely changed. So, and we're seeing anecdotally more folks that were very skeptical, very, very good programmers. And I'm pointing to Linus Torvalds, who in the last week has started vibe coding. right? Now it's not in the Linux kernel. I don't think it's going to be the Linux kernel is going to be vibe coded anytime soon. But the fact that they're relatively impressed with the capability. We also see this in the sciences, right? And so I'm a theoretical chemist. We see at the beginning of this year, January 2nd, that folks are coming out with, hey, we're going to have agentic computational chemistry, right? And that's going to democratize the use of these models, and that worries me a lot as a computational or theoretical chemist. Um, there is papers that are being published. So this is the ACS Proteomics Journal from a week ago. And literally the title is Vibe Coding for Omics. And the entire paper is about how you can use LLMs to create omics code in a very short time. I think he says 10 minutes, right? Or so, right? And so we see these things in the sciences, right? We also have the data problem, right? And that we talked about this a little bit yesterday of, AI ready data. Is your data, accessible? Is it connectable, right? Or is it siloed? All of these attributes that you need in order to really materialize the vision. I mentioned in my talk a little bit earlier about this idea of context graphs. So it's not just recording information about individual data objects, but it's also the context around them, right? How the decisions to, say, for example, on an instrument, set particular set of parameters for that instrument, right? That goes into reuse, right? So somebody at the other end who may be trying to decide whether A, your data is useful for analysis or supporting another set of experiments, or in terms of reproducibility, replicability, all of these other sorts of things, right? It's important to have that context of the decisions and the background, not just the settings necessarily themselves. So the last thing I'll talk about, and then we'll move to the panel, is that I did want to clarify that these LLMs have very good parametric knowledge in terms of being able to spit back facts, right? They're getting better. They still hallucinate. They're being trained for generalization, so that way you use techniques like retrieval augmented generation or the new fancy context engineering or whatever the thing is to bring factual information into the context window and then use that as the basis for returning knowledge. But there's these things in the world that humans, deeply have, which is expertise and experience, right? And these typically are long-tail data, objects in terms of there's not a lot of training data that tells a LLM how to start a software project and push that software project in a maintainable, understandable, all of these attributes that a human, software engineer who's managed many open source projects would have, right? And that's hard to actually teach a model, right? Okay, so this is the sort of topic for the panel, and then will sort of move and introduce everyone. Is how do we move from experimentation to this embedded intelligence? And we want to do that in a realistic, effective, and trustworthy manner. The framework is going to be around three different questions. So first of all, I'd like to sort of set the ground truth. Then I'd like to talk as a second topic about pathways that work and how to integrate things. And then the third area is how do we set up governance around the AI, particularly AI in science. And I will point out that the LLMs have created, obviously you see Notebook LM, so you can see what it thought of the various topics, but I have actual questions that I've created. Okay, so I'm going to move to our panelists, and I'm going to stop sharing for 1 second here, so that way our panelists can be brought up. And so we have, and I'm going to go through sort of in order here of what I see on the screen. So I see Cogan first. So Cogan is Kogen Shimizu. He is faculty at Wright State University. He and I go back quite far in terms of the old school sort of symbolic approach to AI, and particularly AI and science. But he's been involved with open knowledge networks, particularly with the NSF, and he has a lot of expertise in terms of sort of the combining these LLM approaches with these sort of old school approaches. So I'm going to let him introduce himself, and talk a little bit about OKNs and everything for about a couple minutes here.
Great. Hi. Yeah, thanks for the introduction, Chuck. Yeah, I think this year is 10 years now, to put a timeline on how long we've known and worked together. Um, but yeah, like Chuck said, I'm at Wright State University in Dayton, Ohio, in right next to the Wright-Patterson Air Force Base. And I'm a knowledge graphs guy. So as Chuck said, the really focused on the symbolic sort of stuff, but very recently, as I think many people have gone, is the integration between the sort of symbolic AI plus all of this other neural AI stuff, and working on this sort of neuro-symbolic AI space. In terms of grants and projects and the things that I see in terms of like AI or embedded AI and embedded intelligence, I'm working with the prototype open knowledge network with the NSF. So I lead an education focused grant where it's really proselytization about how symbolic AI helps large facilities, large programs, large projects integrate their data together so that way they get a little bit more bang for their buck, so to speak, as it pertains to the different projects, and really making sure that money is being spent wisely, especially as kind of belts are tightening in the last few years. There's been some interesting focus on how scientists are not leaving the lab as often, right? There was an article on Hacker News yesterday talking about how ecologists seem to be losing touch with actual ecology, and they sort of are transitioning towards dry labs. And symbolic AI really helps in these courses, or in these areas, in order to make sure that the data is useful in the future, that context is retained over years, and justifies some of the effort and so on. Um, I don't think I have much more to say in terms of introduction. I think Chuck covered most of it, but I'm happy to be here and happy to provide some of the experiences that I've had in integrating large knowledge graphs, to make sure that they're useful for data moving forward. Thank you.
Thanks. That's fantastic. Okay, so the next person I see on my screen is Dean Wampler, of the AI Alliance and of IBM. And so one of the things when I was thinking about today in the panel, and if you read my tech report, is I wanted to draw an experience of the early adopters in industry also. And they're trying to do this stuff at scale. And so Dean has been working as part of the AI Alliance, and he'll do an introduction, I'm sure. But it's a very interesting community that I think this community should know about in terms of trying to bring about academic and private industry and institutional, sort of constituents to start talking about how we use AI in a variety of different contexts. So thanks, Dean, for accepting and being here.
It's my pleasure. It's great to see you all. Yeah, so Dean Wampler, I also started my career as a scientist, as a theoretical physicist. I've been in recovery ever since, I guess you could say. But mostly been doing software engineering for a long time. And so I come at this problem of how do we be successful with AI from, what are the requirements for a software engineer to actually successfully build applications with this stuff? And there's a lot of things that have come up that we've addressed or trying to address in the Alliance, and some of the members of the panel I know are working on some of these technologies. Everything from how do we know that they're safe, that they're not going to swear at the customer or other things we don't want them to do. And in particular, lately I've been working on a project to bridge the gap between what developers are accustomed to, which is mostly deterministic behavior. Not, software is never purely deterministic, especially in a distributed world. But that's a problem that's fairly well constrained. We know how to deal with it. What developers don't understand is the stochasticity of generative AI, that it's, follows a probability distribution. It's something that's very alien to most of them. So this project, which we're calling Testing Generative AI Agent Applications, is really about helping developers understand the core techniques that data scientists and model builders and so forth use, adapt those techniques to their processes of test-driven development or related techniques, and then actually be able to feel confident that they can test their applications that work as expected. So that's one of the major areas that, going from, proof of concept or prototype to production is one of those practical blockers that people are running into. And there's plenty of other things too about data. Can you trust the data being used? Are you going to get sued if the model spits out copyrighted data? Lots of things that a lot of us are concerned about as well. For me, though, this is a problem coming from a developer background that is underappreciated, but is actually probably one of the blockers of those 95% of projects or whatever that number really is. And so that's one of the areas I focus on.
Excellent. Thank you. So our next panelist is Kyle Chard, and he is at Globus University of Chicago, and he's actually been implementing, some AI and agents in cyber infrastructure, and has some really interesting experience that I think he can lend in terms of practical integration of AI into cyber infrastructure. So I'll let him introduce himself.
Awesome. Thanks. Hi, everyone. Thanks for the invitation. Appreciate it. Yes, I'm Kyle Chard. I'm at the University of Chicago and also on the Argonne National Lab, and I wear a few hats, including one on the Globus team. So I think there's two areas of interest here that may relate to this panel. The first is the work from the Globus perspective on AI in distributed federated infrastructure, on which we're seeing a lot of applications, vertical applications being built in the AI space that are leveraging Globus capabilities for managing data, computation, workflows, etc. Some examples that I think may be interesting to the community here would be around federated learning, the AppFul project out of Argonne, Ravi Maduri and Quebec Kim, that enables models to be trained across federated computing infrastructure while retaining that data sovereignty, which is important for scenarios like medical applications, increasingly for international applications where there's very strict data sovereignty rules, through to other projects around distributed training and publication and on-demand inference of models. And then, as Chuck alluded to there, our work recently with agents over the last year or so, we've been building out an agentic framework called Academy, which is a middleware designed sort of ground up to deliver capabilities for deploying and managing agents that are deployed in federated ecosystems. So a lot of the work you see coming from industry around agents has been sort of coming more from the centralized, and LLM is driving decision making, LLM playing different roles, talking to each other to make decisions. What we've been focused on is how do we think about this from the cyber infrastructure up? If we assume we've got facilities and infrastructure, like an instrument, like a computing facility, like a storage environment, in which we want to deploy agents that are going to fill some role, and then we want to enable those agents to be able to work together to achieve some scientific goal. What's the middleware, the glue, the infrastructure we need to enable that type of ecosystem to be delivered? And that's what we've got with this Academy system. So it enables us to deploy agents, to communicate securely between them, to be able to embed language models, reasoning capabilities at the edge in this federated infrastructure. And we're seeing over the last 6 months or so, probably reasonably good adoption in science. We've got applications in materials and chemistry, cosmology. We had an amazing student actually last summer through the CI Compass program who worked with us, an intern out of Bonnie Hurwitz lab, working on a biology application. And I'd love to talk more about that at some point. I think that's it. Happy to chat about some of our experiences. I think there's a lot of really big unknowns, a lot of interesting problems that still need to be overcome to see this really democratized.
Thanks. And our last panelist is Raj Mishra. Hopefully I've gotten that name correct, pronunciation. And he is at WHOI, and he's a faculty member. He's to bring sort of, once again, this real world perspective of applying AI to real world oceanographic challenges. So I will let him introduce himself.
Yeah, thank you for the introduction, Chuck, and appreciate the opportunity to share some of our experiences at WHOI. My role is I manage a team of about 12 developers, and the group was formed about 7, 8 years ago primarily as software developers. And during the past about 3, 4 years, we've had now a mixture of folks with ML skills and particularly operationalizing, machine learning. So my interest is taking tools, automating them, making them useful for science and engineering departments throughout WHOI. At WHOI, our infrastructure, we have an on-premises data center that includes a high-performance computing cluster, about 10 GPU nodes. What we've realized is, and that cluster supports batch job sort of operational flows. It's primarily for training, but we found that to be a bottleneck in a lot of the ML workflows, and we've purchased an on-demand, about 4 GPU single sort of rack-mounted server that has about 750 gigabytes of memory that supports on-demand dedicated sort of workflows. Um, the we have a wide range of projects at WHOI that for the Oceanographic that we support. Both, I think some of the talks yesterday, especially focused around the commercial model offerings versus ML and techniques. And although our ML developers on my team are skilled in ML techniques, we found that there was a wellspring of use of commercial models during the past year, especially. And from a governance point of view, of course, that was a cause of concern to our leaders in the IT area. And so what we did was we instituted, we purchased licenses with OpenAI's ChatGPT models, and it's an enterprise license that has allowed us some more control institutionally over the data governance side. And we found an advantage of, having our scientists, students, staff, and, employees at WHOI leverage an enterprise-grade platform where at least the data agreements are more suitable to the institution rather than the click-through consumer-grade version of ChatGPT that you normally might use. So I'm happy to share more experiences, especially around the risks and mitigation approaches that we've taken at WHOI, but really honored to be part of this panel today.
Thank you. That's fantastic. Okay, so let's get into our sort of first set of topics or ground truth. And so the first part of the discussion is it's the boring part of the discussion is how do we cut through the hype and how do we establish you're a major facility and you are working in a particular domain. What is the boring thing that you could do with AI, not the necessarily the hypey thing? And I'm saying that with the realization that the boring thing may actually be rapidly changing in and of itself, right? And so the capabilities in the boring part of this seems to be that whatever we were doing a year ago may now be the boring thing, right? So would anyone like to take a stab at that?
Well, I'll take a quick stab just because we
Okay.
have developers that are software engineers, and the boring task for them is the mundane, esoteric aspects of taking a framework and writing some template code, example code, and building on that. And we found the use of at least Claude and a few of the commercial models, as well as open weights models. I want to stress that folks shouldn't be resigned to just using commercially pre-trained models, but you have the opportunity, and we use VLLM, Olama, and other open weights models to experiment. And what we have found is, at least from my team, about a 30% increase in productivity by removing those mundane software engineering tasks, including testing. The generation of test cases and test code from these models really obviates a lot of time. We'll stop there.
Thank you. Anyone else want to comment on boring?
I'll just add that in general, that seems to be where AI has been most successful is these sort of human in the loop, productivity improvement aspects of not just software, but any sort of knowledge work. What isn't really working, it seems so far, are the attempts to create very sophisticated autonomous systems where you don't have human in the loop. That's where we still have a lot of work to do to make those successful.
So Kyle and Cogan, any thoughts?
Yeah, I mean, I think we're seeing a lot of value just from these very large models in terms of what they can do for the mundane for a lot of scientific applications. I think one thing to take a maybe contrarian view is that it's also empowering a lot of exploration and a lot of sort of ground up vibe coding, for which I think I'm trying to choose my words very carefully here, but we're ending up with a lot of sort of siloed implementations of vertical uh, science-specific applications that are being built that can be pulled together very, very quickly and can achieve fairly remarkable successes in a very short period of time. What we're seeing now is that we're working with a lot of groups who have built these verticals, and they work great on a laptop in a very controlled scenario. But when we come to try and now take this to the next level, now we want to actually deploy this for some sort of facility, or we want to deploy it, share it with our friends, and enable that to be used somewhere else. There's a lot of roadblocks, and those roadblocks are anything from sort of the assumptions that are made, the security, the scaling, representations, data, et cetera, et cetera. And so I think we do need a little bit more, maybe I sound like an old person here, maybe a little bit more of a cautious approach to how we build ground up. Vibe coding is wonderful for what it can do, but I think we need to build on sort of some foundations that enable some of these more what you would think of as more plumbing type CIE problems to be more easily dealt with.
Cogan, any comments?
Maybe. I think this is a little bit outside of where I sit because I'm not specifically a developer, right?
Hmm.
And a lot of the value that perhaps I see in the boring stuff is probably just data annotation, right?
Hmm.
And semantic harmonization, at least the first step in that, which is the basic mappings between different vocabularies. This is historically a extremely time intensive process, choosing the right unit, when now you can just kind of have this sort of resource. However, as Dean was saying, I think the human in the loop is still incredibly important there because sense is also often missed, and so is context, which an LLM or some sort of agent can sometimes assume, but the human has a broader context, which is sort of implicit, not just to the task at hand, but to perhaps the whole domain, specific niche domain. Hopefully
So
that was towards your question.
yeah, no, I think that this is, part of the broader perspective of, there's sort of, tried and true things that I think from a developer's perspective, like what can you use these things for? But also, ML and, very simple AI, neural network based, machine learning, are pretty well established things, right? And one of the things that I think couples the old and the new together that I'd like to get the panel's opinion on is, there or average scientists, right, who are domain experts, don't necessarily have time to go and become deep experts in other areas. And so one of the things that I've used vibe coding a lot for is to understand different frameworks and explore sort of possibility space, as it were, right? So in the past, right, I might have to solve a particular problem said, I don't really have time to explore all the possibilities here. So I'm going to take the maximum likelihood, sort of a part of probability space and say, yeah, this is the thing that I'm going to go with, right? But that in some ways is just a weighted guess, right? I'm doing Monte Carlo. And so what, sort of vibe coding let me do, and has let me do is, and this is not production code, right? And in fact, I've created a lot of vibe code that will never see the light of day, but that I then did some analysis and sort of summarization and condensation on condensing down what was created by the code agent, and then using that as the starting point for doing something proper, right? And I was wondering if anyone has had that similar experience and it could comment on sort of, I think this is something A, that's real, but I also think B, it's quite useful in being able to explore alternatives that one might not have possibly explored through lack of knowledge of a particular framework or a particular algorithm or a particular methodology that then is now opened up to you. So, anyone like to talk?
I think another example that, sorry, Cogan, looks like you're about to jump in, is actually learning. So you probably learned a lot from those experiments that just sort of the gist of what you needed to know that eliminated the need to paw through documentation that may not be at the right level of detail or to the point. Even if you I actually think this is maybe something that's underappreciated, in fact, because there's so many frameworks. Historically, this has been true for almost any problem we've needed to solve. And if an AI tool could help us very quickly get the gist of which ones seem to be best to pursue for the next level of depth, I think that could be a really underappreciated, boring thing to do, going back to your previous question.
Yeah, maybe just to add to that, what we have found working with scientists and oceanographers, it's a wide field, a broad field with physical oceanography as well as marine biology that span. And what we've found is with ML, especially with ML techniques, you can get easily into rabbit holes. And scientists have easily been able to kind of get there without the proper knowledge of the underlying mathematics of machine learning techniques. So what we did was we had a 4-day hackathon exercise last summer, where we invited folks, including not just students, but engineers and scientists throughout WHOI. And some of them, experiment with techniques that they didn't use before, not just the novice one that learned basic techniques. And they sort of switched, understanding when to use a variational autoencoder for an unsupervised technique versus using a neural network to try to solve, convolutional neural network to solve an imaging computer vision problem, and seeing the differences of how that occurs and the results and the rabbit holes you can avoid through just, education training. And I think that is sort of the key here for us at WHOI is spend more time with the scientific community to share techniques and our understanding of them.
So, Kogan, you had a comment?
I think Raj stole my thunder there.
I apologize, Kogan. Sorry.
But I think if I can pivot a little bit, thinking about research and how vibe coding or similar approaches to vibe coding helps research, I think is in both literature survey, not necessarily trusting references or anything, but looking at vocabulary that it uses or particular phrases and strings that are very valuable to understanding a new domain, right? To getting that top level thing of other things to search for. And then similarly, it tends to be, or these tools tend to be pretty good at suggesting shallow gaps in understanding of the field at large. And this can be helpful for students to contextualize their own understanding, or not just students, any particular learner of a new domain, what they can and cannot trust a new domain or a new framework or a new paradigm or theory to do for them.
So, since Raj brought up, I think, an interesting point, and I alluded to this in um, my intro slides, I'm going to riff on it a little bit of this difference between, and we're seeing this in software engineering also, that I alluded to, that the LMs are becoming quite good coders, and they're coming quite good at creating what a human would evaluate as good code. What they don't have are long task trajectories, and they don't have domain expertise. And Raj sort of alluded to that in the fact that, there's a lot of pitfalls that expertise alleviates, right? And I can give an example from, I put up that slide of the RCS article on computational chemistry agents. And as a theoretical chemist who did first principles sort of development work, that worries me a lot because I've seen a lot of very knowledgeable, well-meaning scientists go and apply a computational model in an area where that model should never have been done, and then draw inferences from the consequences of that model without really understanding that it should have never been used for that purpose, right? And so this is why I like to make these sort of distinctions between the fact that if you ask an LLM, like it will tell you, oh yeah, that's right. This may not be the best approach. But then, when you actually are doing an agentic task or an agentic coding task or even a human in the loop task, unless you bring that sort of information, that expertise into its context, it may not necessarily focus on that information. That's one of the drawbacks to the way that these LLMs work, right? Is that you sort of have to dynamically be able to bring this sort of information into its context so that it can make those sorts of suggestions or decisions for you. And so I was sort of wondering, since it was brought up, what the panel might think about that, and then we'll get. I see that we do have a question. I will get to that right after this, if that's okay. So, I think I saw Raj nodding, so I'll let him comment on.
No, I'm just relating
his experience.
to what you were saying, Chuck, with the experience that we've had here in my team. Yeah, it's the I think from use of these generative AI models, as opposed to the ML techniques, the complexity of interpretation of the outputs and the data, and especially the methods, including fine tuning and prompt generation that could have sort of envelope the actual models, can actually make things more complicated and complex. So there, and Occam's razor, if you want to keep it simple, it's adding more opportunities for misinterpretation. And what we try to do is try to boil it in essence down to what we need. And for instance, the use of RAG, I'll give you an example, is um, is is trying to leverage the natural language processing capabilities of the models only, not its pre-trained knowledge base. It's not to draw the biases that may exist in how the models were trained, but just utilize the essence of its understanding of the associations of concepts in language, and that's it. No more, no less, right? If there was a way just to do that simply, you would see more consistency, accuracy, and some of the points that Dean raised about having more reliability in the model outputs.
So I'll riff on that just one second. That in my intro video, which I think we posted to the chat, I go through a discussion about memorization versus generalization, and that for a lot of agentic tasks, what you want is a model that's well generalized but may not have a lot of memorization. So it has these sort of abstract capabilities, but it uses tool use and other sorts of things in order to factually navigate the world, so to speak, right? And so I think this sort of goes back to your point of sometimes the best model for doing something is actually the dumbest model that's for doing something in terms of parametric knowledge, but may have very good generalization, as a result. And we still don't quite understand how to do this fine tuning yet, right? So. So Kyle, you have any experiences along
Yeah,
those lines, or?
I mean, I work with a lot of students, and I would say, I mean, for a long time, people have been using models, techniques, methods incorrectly, and a lot of it's always difficult to find those problems sometimes after the fact, etc. So I'm not sure it's actually any worse. I'm not sure we're in a position that is worse than what we were in before in terms of people adopting tools that they hadn't completely understood, and perhaps even the size and knowledge base that underlies many of these large models is possibly better. And the adoption of sort of agentic type approaches where the models themselves are playing sort of devil's advocate roles and actually sort of reasoning with themselves around the right approaches may well lead us to a better position in terms of empowering people that otherwise don't have those capabilities.
So I'm going to play devil's advocate for 1 second and then see if the panel has any reaction. So one of the things that concerns me though is drawing scientific conclusions, which is a very different thing than constructing code. And so if you're relying on the model to draw a scientific conclusion, what are the attributes that we need from models? So what are the attributes we need from, say, science foundation models or science models that might be different than just regular LLMs? And this goes back to my idea of hey, how do we do falsifiability with a LLM that's spitting out stuff that I have no introspection to be able to falsify in some ways, right? And even if it's using a tool like ML and constructing you can use a code agent, right, to build you a PyTorch algorithm to implement X, Y, and Z algorithm, right? There, that you now have an AI which is potentially making some assumptions when it makes that implementation of the model, and that model now has assumptions that then are going to be propagated into any scientific output of that model if you're using that as an agent. So I was wondering, what does the panel think about this, or has the panel thought about this?
Maybe
It's
just to clarify your question, Chuck, are you asking like how scientific or like generative AI for scientific applications does or does not contribute to the sort of like black box effect? Or like how can we trust its output for these more rigorous use case applications?
So So I don't know that I have an answer. I guess that's probably why I'm posing the question. But I think that the black box problem is something of a problem, but that the context around the black box can often tell you and give you hints as to what the black box is doing, and that may be in terms of source code implementation that an LLM can tell you about or it may be, in terms of other methods for doing introspection in the model. So mechanistic interpretability is a fancy way of saying that sometimes you can tell what the models are doing through statistical processes. So this is, I think, sort of alluding to some of the things that Dean might be interested in his research. And so my question is sort of twofold. One is sort of this general question about the essentially the trustworthiness of the model. But two, when you're using a model for science, that demands some extra constraints on the process and the model and what folks thought about what those constraints are and on that process and what the requirements are for a model that is being used for that.
Yeah, if I can give a thought there is if you regard traditional software engineering validation procedures like a system under test, right? You draw a box around that black box. And then we have had success with scientists who've used signal processing techniques for various types of image, object detection, computer vision type techniques. And when we use ML as a substitute or a competing mechanism to those approaches, you can still leverage that system under test and validation process that they were using in the past for signal processing techniques, looking at test vectors, looking at their outputs, making sure that that level of confidence that they had in traditional approaches at the least applies to the ML algorithms that are substituting in, and even without the explainability behind how it's getting to the answer. Because at the end of the day, the scientists care about the hypothesis testing and what the result is, whether it's traditional approaches or the more novel, newer approaches.
So Dean, I'm interested in poking your brain now because you mentioned, at the beginning that you were trying to, in terms of, testability, and this is more at traditional software development, but I think that there's a lot of, your ideas that are along these lines, particularly the statistical approaches and trying to remind people, even scientists who are using these things that these are statistical models underneath. So what what do you think?
Yeah, I don't know if I have a great answer, but I'll throw out some things that I know people are using. Like, for example, for code generation, you can always run the code through compilers, linters, and so forth, using complementary tools to validate what's coming out. And I know there's some people in IBM research who've been building chemistry models for predicting, new molecules. And what do? They immediately send it to a lab to see if it's actually synthesizable, if this is a real chemical. So I think that's one of the areas I would search for. Even in the pure information space, I've done things like use other LLMs to validate the outputs. Like, do you think this output actually is good? And sometimes if they agree, then you don't have to focus on anything except where they disagree, because that's usually where the interesting problems are. And I think also just to something that's been alluded to several times, we'll probably get to the point where models, or maybe it's agents working with models, that are most appealing in these sort of, high demand requirements kind of scenarios. They'll have to be really good at attribution. They'll have to really justify their work, their reasoning, or where did you get this information? And if they can't do that, then we'll just have to be a lot more skeptical about the results. But so far, we haven't done a good job making things actually justify their reasoning, although we are getting better at that sort of stuff.
So thank you for that segue because now I'm going to talk to Cogan for a second here because I think that one of the other questions in my mind is in terms of what tokens are good knowledge representations for models, and in particular. There's been a lot of research on context rot and should we, fine tune a model for XML structures and how do we actually, sort of activate the model pathways that are the appropriate ones given a particular set of input tokens. And a lot of folks are sort of now moving, or at least thinking about, particularly with respect to planning, of using the sort of symbolic, part of the process as a tool, right? And so basically saying, here's a tool, but that tool is verifiable, deterministic in some sense. It's like a compiler, right? So I have certain guarantees that are mathematical theoretical guarantees that LLVM will do X, Y, and Z given a particular set of input, right? And so I think there's some interesting things that people are thinking about is how can you use that as sort of a tool for the model. And I was wondering if you had any thoughts or any insight into what that might look like, sort of based off of this verifiability thing that I think that Dean was talking about a little bit.
Oh boy, good question. So I would say that there's a lot of interest in this right now, this sort of capturing somehow domain or physical laws, right? Domain science or physics, kind of like a physics informed something, and then incorporating it with generative AI. To the extent that this is actually actualizable, I think is really much really an open question. Very many people are interested in, and I think I can talk a little bit about what's going on over at the Air Force Research Laboratory, which is across the street from me. And they're very interested in model-based system engineering. Like that's where I don't know, the last 8 years of their investment has gone in terms of simulation, in terms of having reusable data and knowledge artifacts for their stuff. And then all of a sudden these LLMs come in and they're like, okay, well, now how do we make these two things work together? And one of the mechanisms that we're investigating is that OWL, for example, is a subset of the UML that SysML, sorry, a lot of acronyms there, that they use for their model-based system engineering, and they should be interoperable. And so being able to leverage this sort of rigorous verifiable knowledge model that we would historically call an ontology is now something that we can incorporate directly into something that we would now call a physics-informed reasoner, and that you can describe its functionality and its stuff and hook that into an LLM. So this is something that I think is really ongoing, and these various takes on that sort of architecture is a lot of what I'm seeing around. I think in their materials and manufacturing thing, they're looking into autonomous experimentation, self-driving labs, all that really cool Jarvis Marvel stuff, right? And for them, they're not necessarily looking at verifiable in the sense that it's deterministic, but that it's somehow grounded in a theory, right? And so they're still doing probabilistic patterns. So it's not necessarily deterministic in the sense that you'll get the same output, but it's somehow a notion of optimized for their specific thing, and also trying to incorporate these sort of fact checkers in their hypothesis generation or their search space seeking with an LLM or generative AI tool is also on their minds.
Thanks. So I'm going to riff off that to Kyle.
Chuck,
Yep.
can I interrupt you, because remember Jameson had his hand up some time
Oh,
ago.
yes.
And so Jameson, if you still want to ask a question, now might be a good time.
Now would be a great time.
Yeah, sorry, Chuck.
Yeah, I mean, it was a little bit about a discussion from a while ago, and I just kind of a little bit wanted to reiterate a point I made yesterday and kind of agree with some of the points that were made about agentic coding and the use of agents in general, and the lack of domain knowledge that they seem to, in some sense, encourage. And I'm particularly concerned about this. And so I kind of will reiterate it because I really want to understand how people are attacking this problem. And, I very much hope that they are. So, again, the thing that I've seen, which is very concerning to me, is that these, particularly these coding agents, allow young researchers to be much more powerful in an extremely dangerous way, in that they can generate code that can do something, and they have no idea what it's doing. And they also seem emboldened to do it anyway because of a kind of trust that the agents are correct, when in fact, as you guys point out, they have zero domain knowledge. And usually for scientific experiments, the experiments, the apparatus, the systems are very esoteric. They're not things that these models would have any exposure to, really. And so I'm just very worried about the trend of just letting go of the experience and the need to understand things, and just letting the models kind of do everything for you, and how that that applies to both agentic programming and the use of agents, but I think it also can apply to things like data analysis, where I take the one panelist's comment about whether or not this is actually a worse situation in terms of how people were applying models, machine learning models in the past without knowledge about how they actually work or if they're applicable to the situation. But I think that the new domain kind of supercharges that, where, you just let an agent do something, do an analysis, and you just kind of assume that it's doing it correctly. It may or may not be, but as we lean into this as a society, the humans just have less and less understanding of the domain because they've, passed more of it on. I feel like we're heading to a crisis with this, where there just becomes this big gap between who actually understands what's going on underneath. I mean, maybe the agents do, but in my experience, they don't. So, but we're not also giving the people coming in the experience they need to actually understand what's going on either. So, I don't know how we're supposed to handle this. I feel like we need more. There needs to be some reconciliation about how we're headed with this trend. But so anyway, I'm very curious to hear how the panelists think about those kinds of issues. Thanks for taking my call.
No, thank you. I think that's fantastic.
Yeah, just to share, I mean, my concern there too is just being in the software engineering industry for most of my career, that evolution to being going from a programmer to a software architect required a lot of development and practical sort of application development and so forth in software engineering. And my concern is that use of these models will kind of sort of risk those architectural pieces. How do you build an architecture together? And so one best practice that we try to inculcate with the folks we work with at WHOI is use the coding output, the code that these generative AI models, as initial examples of how particular problem can be solved, or at least a certain framework can be used, but don't employ it straight into your production code. There's a little bit of design work still that needs to be done to how to use that code and re-employ it for the end use cases that it's going to challenge. So use code as examples rather than directly into production.
Yeah, I actually agree with the question as well. I was the one that earlier said, is it any worse than what it used to be? And I think an interesting question there is, over time you sort of grow confidence and experience working with people and knowing sort of their capabilities. The first few times you work with them, you'll know, well, okay, I need to fine-tooth comb, go through lower level and see what's happening. I think similar things will happen with agents. One anecdote or a story, recently we had some code that was given to us by a domain scientist that was an agentic system doing X. And one of my students started reviewing that code and found that the piece of that code that was actually calling a simulation model had been stubbed by the AI and was just producing sort of random results. And the scientist did not know that piece had been stubbed out. They thought they were using some underlying simulation code. So it's those types of things. And I guess there's two pieces of trust. We hadn't worked with this group before, so I guess we needed to know that, well, maybe we needed to dig a little bit deeper. And two, I guess the trust in the model to know what it's actually doing. And I think a lot of our work, I mean, I'm sure you're all seeing this, is changing. The amount of stuff that I'm being given now that's AI generated code, presentations, documents, I feel like my job is turned into a reviewer more than a producer of stuff at the moment. And I wonder when that is going to change and how that's going to change.
Yeah, that comment really, really resonates with me, because I think that people don't, you absolutely have to become just a full-time reviewer, which is, and the burden on a reviewer is much more significant than I think people give it credit for, because I think that people are used to kind of a cursory review of other human producers because you have some sort of implicit trust that they're going to not do things like stub out the model, right? Because they know that they stub out the simulation because they know that that is nonsensical. But, so you have to really, with the agentically programmed code, vibe coded or whatever, I feel like you really have to go through it with a much finer tooth comb than people are really, appreciating. And I don't see a corresponding increase in the attention of review that is needed. And because review sucks. People don't want to do review. It's not the fun task. So yeah, this is that what you just said is very much resonates with me and my experience. And that's kind of what's driving my deep concern over where we're headed with this stuff right now.
So one quick comment that in my intro slides I said that there was a agentic coding experiment from last summer that showed a 19% decrease in productivity, and the main contribution of that was actually exactly that overhead task of review, right? That in established projects that had reputation, right? You do not want a stubbed out thing that you think works actually going out in production, right? Or released as a set of code to the world. And so that was a lot of the overhead that was, sort of there, but a lot of the programmers underestimated that overhead. Which I think was the interesting part of the paper, because if you ask the programmer, they thought overall they were more productive, but because there were metrics behind it, they actually understood it. And I see Ava has come online, which means we have a question for the audience.
Yes, there's a
as
question.
We're wrapping up the panel.
There is a question. Yeah, there is a question in the chat from Pavan Nara. I can read it, or Pavan, you can voice it yourself. I'll give you a second to unmute if you want to.
Hello everyone. My name is Pavan. I'm from Internet 2. I'm an AI specialist over Internet 2. So my question, it is a gray area, I might say that. So my question is that can AI be really creative? It might be a overstatement to say that it can be, because I believe that AI tools such as RAG models or agentic frameworks that we create, which have a very specific purpose in mind. So for example, if I create an agent to do a specific thing, it will definitely do that. But when conversational AI such as ChatGPT and different LLMs has made knowledge very accessible to people, so while it can also give you ideas which we might not think at that moment, but I also believe that it can also limit creativity by shaping how we explore or frame different ideas or problems. So I just wanted to hear ideas from the panelists. That's it.
I can jump in for this really quickly, mostly because I worry the same, but also I think in the same way that Kyle has been saying, it's like I'm not sure how much it's actually changed, right? Because in the same way that you might ask an LLM and it frames your creative process or informs somehow your intuition, we all have mentors, right? We all have colleagues that will ask, and frequently sometimes they put us down the wrong path because their intuition has failed, or this is also why we suggest, like in the academic trajectory, right, that for your postdoc you go to someone else, right? You find a new person to be educated under, to be supervised by. And so while I appreciate also, I think the cagedness that can come from relying on an LLM, I also wonder how different it is. I guess in some sense it might be that because everybody's using the same limited set of LLMs, right? This is kind of like everybody having the same mentor, and so this might be something. But as long as we keep the human side of it relevant and impactful, I think we should still be fine. And then on the other hand, I think there's this sort of metaphysical question of what actually is creativity, and are humans creative anyway, right? So there
Yeah.
you
So I do want to put up a question. So Nikki, do we have the question right now?
Yes, we do.
So we have a question here, and we'll give you a few minutes to answer that question. And while you're doing that, I will sort of riff a little bit on Cogan's answer of it's unknown at this point. I mean, this is actually an active area of research. Is can a AI, a large language model, come up with a novel hypothesis, right? Can it generalize, out of it's out of distribution, right? Essentially, like out of the distribution that it's been trained on, and come up with novel ideas. A lot of the research that I've seen is using essentially tools to do that, though. And so whether it's coming up with other knowledge representations, hypergraphs, other sorts of machine learning to then inform, sort of this agentic process, there is this underlying question of, these things are stochastic. So they are sampling, distributions, and people are interested in what their out of distribution, quote unquote, out of distribution response is, right? And they are, certainly under circumstances capable of out of distribution, but they're not, they're the fine tuning in terms of the process by which you create a language model or any of these AIs, right? Is that you're changing the underlying behavior of the model based off of the type of behavior you would like the model to express. And so that in and of itself, causes issues in terms of, what should a hypothesis model maybe look like. So yeah, I think that is a much more general question. So okay, so we have Nikki, how much more time? Another minute or two to submit
Yeah. Let's say
answers?
one more minute. We have until the panel ends at 10:55 or
Okay, that's what I was guessing.
1:57.
Is we had about 5 minutes left to wrap up. Um, was there anything the panel would like to sort of close with in the last minute? Any burning comment or thing that sort of jumped out that they'd like to comment on?
Well, just a little bit of a jump. What we like to do is for creativity, use generative AI to generate logos for our applications. Pretty much.
Yeah,
That's it, something that has low impact.
and acronyms, like, it is very good at if you for those of you, a hint, if you're writing a proposal, uh
I'll just add one comment. This is maybe an open question for people to think about, but what is the right abstraction we should be giving scientists or other non-technical AI savvy people that we want them to successfully use AI? Is really the prompt like the worst possible thing to give them? Or should we give them something that's maybe a little more aligned with how they think about the world and hence are less likely to mess it up?
Yeah, I think that the user experience, user interface, and abstractions, I think, are sort of important. I did put a link to there's a product, not to plug a product, from Answer.ai called Solve It. And think of it as a Jupyter notebook, but on steroids in terms of how you interact with the AI and how the human is in control in terms of a user interface. And so there are people, thinking about this, about how to be able to use AI, but use it in a very careful way. And so I think that back to the education comments earlier about how do we, start to think about, how to do the careful processes and teach those careful processes of how to use these things in a scientific context. Okay, do we have the answers or the poll results?
So Chuck, just like yesterday, we're getting a lot of good answers. So
Excellent.
a lot of answers. So I see Nikki has just closed the poll. If you want to add an answer you didn't have a chance, just put it into the chat, and we'll grab it from there. And we'll be analyzing these results post workshop time, since we have a lot of answers here. At the same time, we're putting them up, just the raw answers, on Google Docs. So I put the link in the chat where you can see what people have put in. And we'll add these results just in a few minutes as well. So you will see what people are saying. And the cloud is nice, but it doesn't really work. Cloud is nice, but I don't
Doesn't
think
capture what the essence is that people are saying.
Right, exactly.
Yeah, this all looks very good. Thank you everyone for contributing. And I think we're near the end of our panel here. So we have, I think, 2 minutes left if there's any short question from the audience. If not, then I would encourage everyone to thank our panelists for spending the time with us today.